All right, so here in lesson 18, we're going to talk about modeling situations with sinusoidal functions, which is essentially what we were doing yesterday with writing equations of trig functions, just putting them into context, giving them a situation. So it says Jade is having a wonderful time riding the carousel. Her distance in feet from the fence nearest the entrance is given by the equation d equals 25 sine of pi t over 15 plus 35, where t is the time in seconds since the carousel started to rotate. All right, so first of all, we're going to sketch what we have going on here, but before I do that, let's just even think about what's going on, right? The carousel is by the fence to the entrance, so let's just call this the fence. And a carousel, right, is that circular ride with the horses or whatever on it. So let's just say Jade is somewhere on this circle. And right now she's this far away from the fence. But as she goes around the circle, her distance starts to get bigger. And then it starts to come back. And then it goes in. And then she comes back. So she goes all the way around. She goes far away, back in, closest, back to start. All right. So I don't think we need a calculator to graph this because I think the numbers work out pretty well. Listen, instead of using y's and x's, they're using d's and t's. So as I go to graph this, we've got our y is our d, which they said distance from the fence is measured in feet. Time is measured in seconds. So I'm going to start with the midline. The midline is 35 and the amplitude is 25. So I'm going to say this is 35, and from there, we're going down 25 or up 25 to get our highs and lows. All right. Now, we also need to address the period, right? Inside, I have pi t divided by 15, which is the same as pi 15ths times t, which means my b is pi 15ths. So period equals 2 pi divided by pi 15ths, or 2 pi times 15 over pi, which means the period is 30. So I'm not going to go all the way out to 30. I'm going to maybe do like this. I'm going to call this one 30. Right now, notice I did 1, 2, 3, 4 subintervals. So I'm going to complete one full sine graph. So sine starts on the midline, goes up to the top, back to the midline, down to the bottom, which is 10, back to the midline. There's one complete sine graph, and that took 30 seconds. So we could do it again, and now I'd be at 60 seconds. Same graph, right? Just now we're doing it again. Because Jade's going to go around this carousel probably more than once, isn't she? Okay. All right, so let's take a look at some of these questions. First question says, how close does Jade get to the fence? Now, when we talk about how close does she get to the fence, I'm looking for the smallest distance from the fence. Now remember, distance from the fence, that's our y. That's our y-axis. So I'm looking for the smallest y value, right? Look at my graph. The lowest I ever get is 10. The smallest distance is 10. Okay. The next question says, how much time does it take for the carousel to complete one revolution? That's asking about one period. Let's go look at our graph again. Like, I'm going back to this picture even. She starts, let's say, 35 feet away, and then she goes to her highest, which is 60 feet away. Then she comes back to 35. Then she's 10 feet away, and she comes back to 35. So this is simulating her completing one go-around, and that took 30 seconds. Okay. Now, this last question says, what is Jade's distance from the fence after 20 seconds? Okay, so I'm going to go back to my graph here. And let's see, if this is 30, this would be 15. And they're asking about what happens when time is 20. They're essentially asking for the point, right? What is the distance? What is the y value when time is 20? Well, we have a formula to find the distance, right? I think we're just going to go plug in our time. So I'm going to say d equals 25 times the sine of pi times 20 over 15 plus 35, right? They said, what is the distance? So they're saying, find the distance when the time is 20. So they're giving us the x and they're asking for the y. I'm going to plug it in. Now I'm just going to use a calculator. So I think we can do just from a calculating screen. Let's make sure we're in radians. And I'm going to go just type in exactly what I have. 25 times the sine of pi times 20 divided by 15. Get out of the sine. And then add 35. And so I look at it and I'm going, yeah, that makes sense on our graph, right? We were just above that minimum there. So I'm looking at like 13.349. So I'm going to say d equals 13.349, and distance is measured in feet. Sorry, I keep moving that down. Right, so we have the equation, and if you know what time it is, you can go find her distance. Okay. So let's go take a look at this next one. It says, Brielle and Elaine are at Sunset Beach. Elaine notices that the water rises and falls throughout the day on the posts of the pier, right? With what we know about tides, the water comes in, the water goes out. They find that the water is at its lowest at 8 a.m. and is 2 feet up the post at this time. They notice later at 2 p.m. that the water level has risen 40 inches to its highest level. So, draw a sketch of this data and use it to write an equation that models the height of the water in terms of time, which is hours after midnight. That means midnight is like when we start the clock. That's time 0. All right, so I'm going to come in here and I'm just going to... So we have the height of the water, and they said, well, they didn't say how we're measuring the height. At one point they talk about feet, and then later they talk about inches. I'm going to be honest, I'd rather call this 24 inches than change 40 inches into feet. That's just me. So let's do the height in inches. All right, so remember, this is midnight. This is time 0. So at 8 a.m., the water is at its lowest, which is 24 inches. They notice at 2 p.m., well, let's see, 2 p.m., how many hours after midnight? Let's see, noon is 12 hours, so 13, 14. So 8 to 14, that's a distance of 6. They notice it's at its highest, and it's risen 40 inches. So it was at 24, and so now we're going up to 64. So they've given us the low, they've given us the high, and that span there is 6 hours. So we can finish this. We can go 6 units over here, that would be 20, and it'd be back at its low. Or we could go 6 this way, that'd be 2 a.m., and it would be back at its high again. Either way, we've got this oscillation, right, with the tides. The tide comes in, tide goes out, tide comes in, tide goes out. All right, so we know what our graph looks like, right? We have the highs and lows. And we're being asked to write an equation. I did not do a good job labeling my axis, right? I did this one. This is time in hours. All right. Well, let's see. Let's talk about our midline. Let's see. Midline is halfway between 24 and 64. That's the average. So when I add them, I get 88. Divide by 2, I get 44. So there's my value for K. My amplitude then is 20, right? I'm going down 20 or up 20. Okay, so I can start writing my equation. I guess I have to decide like what I'm doing here. I kind of like this positive cosine, right? There's one complete cycle from top to top. So I'm going to do a positive cosine. I almost started writing y. We're not calling it y, we're calling it h. H equals, I have 20 cosine of blank, I'm going to fill that in later, plus 44. All right, now the period that, or the portion of the graph I've chosen is starting to the right too. So in here I'm going to have a t minus 2. But what I haven't addressed is the period. So this graph goes from 12 to 14, which is a length of 12. I need to go find my value for b. So period equals 2 pi over b. 12 equals 2 pi over b. Maybe cross multiply. Divide by 12 and reduce. Should get b is equal to pi over 6. So those parentheses in there are a big deal. And yeah, I think we've got our equation. We've got a graph and we've got an equation. Okay. Now, it says use your equation to answer these two questions. A calculator is permitted. So the first question says at 11:30 a.m., let's stop there. 11:30 a.m. is 11.5 hours after midnight. So just kind of translating that into our measurements here. The girls take a walk on the beach. What is the height of the water now? Oh, it's kind of like the question with Jade. I know the time. I'd like to find the y value. Now I'm going to do this one a little bit differently because here's the thing. We don't really know it yet, but we're going to use the graph to answer this question, and then maybe I even want to check my graph here. So I could go and plug my 11.5 in here. There's nothing wrong with that. I'm just going to show you another option. So I'm going to go to my calculator and I'm going to start a graph page. And I'm going to go type in my graph. So I've got 20 times the cosine of pi over 6 parentheses x minus 2. You have to use x's when you graph. It says f of x. You can't use t's in there. Get all the way to the outside and get that plus 44 at the end. Now listen, when I hit enter, I don't see anything. Well, I shouldn't see anything. My y is only going up to 6, but the bottom of my graph is at 24. I'm going to have to change my window. So I hit menu 4-1. I'm going to make my window go, I don't know, how about 0 to 24, right, for hours in a day. I didn't mean to do that. And, you know, you can go up by 1s or 2s or whatever. My y min, I'm going to have it be 0, but my max, this graph is going up to 64. I don't know, maybe I go to 65 or 70. And if I'm going to go up that high, I should probably not have a tick mark every 1 unit. Okay. So this graph should be very similar to this graph, right? Because we changed the window to match. So my question is, what is the y value when the time is 11.5? I know we could just go back to that home screen and type it in, but I'm thinking when time is 11.5, that's somewhere in here, what's the y value? You should be able to do this from the graph. So the way we're going to do this is we're going to hit menu. We're going to go down to trace.
One of your fellow class officers, Ian Robertson. Make sure.
Okay, so I hit menu. I'm going to go down to trace. This is different for us. So I go down to number 5, and then I've got some choices, but we're going to stick with number 1, which is to trace on the graph. Okay. Right now it says, hey, look, I've got these little like kind of crosshairs with this like target here. And I can use my arrows and I can move around, and notice as I move around it's changing. It's telling me where I am on the graph. Well, I want to go to 11.5, so I'm not going to arrow over there. What are the chances that it lands on 11.5? Pretty slim, to be honest. Right? It skipped from 11.7 to 11.4. I'm not going to guess. I'm going to just go type in. Just go to your buttons and just type in 11. Watch what happened. It just started typing in the middle of the screen and said x equals. Yes, that's right, x equals 11.5. And when I hit enter now, it says, okay, when you're at x equals 11.5, here's your y value. Now, it's still in blue. We're still tracing on the graph. The first thing I'm going to do is hit enter. And watch what happens when I hit enter. It pastes that point onto my screen. Now, if I want to find more decimals or do something else, you can see this little square up here is this tracing app, and you can see those little crosshairs are still there. I want to be done tracing. And so to quit this application, I'm going to hit the escape button. And so notice that's gone, the crosshairs are gone, but that point is still there. And that allows me to now go in and hit that plus sign for more digits. So when time is 11.5, the y value or the height is 49.176. So I'm going to write this down. I went menu, I went to trace, and I went to number 1, which is graph trace. And then I just typed in my time, which is really my x value. Okay, then I hit enter, then I hit escape. Actually, I probably hit enter twice. Okay. That's another option. And some of you are like, well, that was actually, it took a lot longer than just going and typing this in. I don't disagree. You're right. Just typing in 11.5 in here would have been faster. But I knew that I was going to use the graph to answer this question. So I was like, if we're going to put it in the graph, let's do everything from the graph. All right, so let's take a look at the next question. It says, Brielle's little brother is 2 feet 7 inches tall. Listen, we're doing everything in inches, so let's just convert that and let's call that 31 inches. What is the first time after 8 a.m. that the water will be over his head if he is right next to the post? So essentially, I want to know, when is the water 31 inches tall, right? That'll be right at the top of his head. So let's go back to the graph. This is the height of the water. This is the time. I'm looking to see when the water level will be about 31. Let me see if I can use a different color here. I grabbed a green pen. Here's 31. And there's a lot of times where the water level will be at 31, right? That'll happen here, that'll happen here, that'll happen here, it'll happen again here. They're essentially saying, find the time when the height is 31. It's the exact opposite of what we did back here. Here they said find the height if you know the time. Here it's find the time if you know the height. So this is why I'm looking at my graph here. First of all, this first one is before 8 a.m., so I don't want that one. It looks like this is the first time after 8 a.m. Because here, before 8 a.m., they're probably eating breakfast. They're probably still in bed. But after 8 a.m., that's the time we're talking about. So I'm going to go to my calculator. And the way that I ask my calculator to do this is to do exactly what we did on paper. I'm going to hit tab, and I'm going to graph another function. I'm going to graph the line y equals 31. Just what I did on paper. Because now I know we don't want that one. That's before 8 a.m. I'm going to look for this point, this intersection. And so I'm going to hit menu. I'm going to go down to number 6, which is Analyze Graph. I'm going to go to number 4, which is Intersection. And I know which one I want. I want this one right here. So I'm going to click on the left side of that intersection. And now it says upper bound, so I'm going to drag it over to the right. And it says it found one, so I'm going to click it again. And here's that point. I'm just going to move it a little bit so we can see it. But it's giving me the coordinates. Now, I know that y is 31. I put that in. Remember, I'm looking for the time. I'm looking for the x. And it looks like that x coordinate, or that time, is 9.649. Hours after midnight. So almost like 9:30 in the morning, right? 9.5 hours, 9:30 in the morning, about, okay? So what did I do here? I graphed the line y equals 31, and I went to go look for intersections, which is menu, number 6, number 4. All right, good. Let's go to the last one. It says Lamage rides his bike over a piece of gum and continues riding his bike at a constant rate. At time 1.25 seconds, the gum is at its maximum height above the ground. And 1 second later, the gum is on the ground again. Well, here's the ground. Right, we're riding our bike. Here's our tire. The gum is at its highest point when it's at the very top of the tire. The gum is at its lowest point when it's stuck between the tire and the ground. All right, so I could start drawing a graph here. We know at 1.25, the gum is at its maximum height. I don't know what that is yet, but I can go put that up here. 1 second later, so 2.2, height is 0, which means another second later, because he's riding at a constant speed, we're back up at the top, or at 4.25, we're back at the bottom. Or perhaps I go back 1 second, which means at 0.25, I'm back at the bottom. All right, well, we can draw this in, right? So I don't have any numbers on the y-axis, but that's okay. All right, so it says if the diameter of the wheel is 68 centimeters. Oh, well, that's helpful. Diameter goes from top to bottom. If that's 68, when the gum is at the top, it's 68 centimeters up. When the gum is at the bottom, it's 0. We already knew that. So I started labeling my axis. We're talking about height of the gum in centimeters, and this is time in seconds. All right, well, we would like to write an equation that models the height of the gum above the ground at any time, and we already have our picture. Awesome, so let's see, we can start drawing in our midline. Halfway between 0 and 68 is 34. And if the midline is 34, to get up to 68 or down to 0, I'm going 34. We just have to decide if we want to do a negative cosine or a positive cosine. I don't know, I just like a positive cosine. So I'm going to start here, top, bottom to top. That's the period that I'm going to use. This graph goes from 1.25 to 3.25, which means my period is 2 seconds. Great. So I think we have everything we need. We've got the height equals the height of the gum is, let's see, we have a positive 34 cosine of blank plus 34. Now my graph is starting to the right, 1.25, so I have t minus 1.25 in there. We just need to go find our value for b. Well, you have period. Period equals 2 pi over b. If the period is 2, 2b equals 2 pi. Divide by 2, which means b equals pi. So we have an equation that models the height in terms of the time. You know what I'm going to do? I'm going to go graph that. So I'm going to start a new page. I'm going to hit Control, Document. See that plus page? So Control Doc, that just starts us from scratch. And I'm going to go graph 34 cosine of pi, I missed the pi, times tx minus 1.25 plus 34. Now, this is wild looking, but again, it doesn't match the numbers I have down here. So let's go do that. Let's do menu 4, 1. Let's have our x-axis go from, I don't know, like 0 to 5. I'll go up by 1s. My minimum, I don't know, 0. The highest my gum gets is 68. I don't know, let's go to 70 again. And let's still go by 10s. Right, so this should match what I have on paper. It does. All right. So let's go look at some questions. It says, what is the height of the gum when Lamaze gets to the end of the block, which is when time is 15.6 seconds? Sorry, I know it's a bad time of day to make videos. Okay, so they gave us the time. We're trying to find the height. So what is the height when the time is 15.6? So again, I can go back to my equation and just go plug in a 15.6 there. That's fine. I can do that. Or we can trace on the graph. I'm actually going to show you a couple things we can do here. So let's review the trace. Menu, number 5, number 1. I'm going to type in my 15.6 and hit enter. Now, it just adjusted the window. We probably didn't even notice. But if you think about it, right now my graph was going from 0 to 5, and we want to go way out here to 15. So when I typed it in, it changed the window. Look at the bottom. It's going from like 12 to something, okay? But that doesn't change the fact that it gives me my y value when my x is 15.6. So I'm going to hit enter to paste that point there, and I'm going to hit escape to get out of that application. Okay. Coincidentally, we get another 40 something. Just so happens these numbers are similar to the question we did about the pier. All right. So I'm going to hover over that y and hit that plus sign to get some more digits. But when time is 15.6, my y value is 49.436. And that's going to be in centimeters.
Your mom's in the front office.
Okay, I want to show you another way to do this that might be a little bit easier than tracing. Now, it is dependent on the fact that you've already put your graph in your y equals, right? But we want to plug in a number into this function. So let's just kind of Algebra 1 review. If I gave you a function f of x and I said go find f of 2, say, oh, that means go plug a 2 in for every x and it spits out a y. That's what I'm going to do here. If I want the height at 15.6, I want to find h of 15.6. But we didn't call the graph h. What did we call the graph? Mine says f3 of x. All right. So I'm going to say I want f3 of 15.6. I'm going to go back to a calculator screen, not a graph screen. So I'm going to add another page. I'm going to go to a calculator page, and I'm just going to go to the bottom of my calculator. I'm going to get the f, then the 3. Look what's happening on the screen up here. I'm going to go back for a second. I hit f. It's kind of this little italics f, but as soon as I put in a 3, it becomes bold, and it stands up straight. And that's the calculator's way of saying, you have something saved there. I'm like, yeah, I know. I'm doing this on purpose. And then I'm going to put in my parentheses and type in my 15.6. So it's just a different way of finding a y value, maybe a little less cumbersome than tracing on the graph. Just go to a home screen. It depends on the fact that you've already have the graph typed in, which we did, and you just type in f3 of 15.6. Awesome. So, two different ways. We can either do trace like we did above, or we can do something like that on a graph screen. All right. Last question says, when, that's a time, are the first and second times the gum reaches a height of 12 centimeters? So they're asking me to find 2 times when h is 12. Same idea. Find the time when h is 31. Find the time when h is 12. I'm going to go back to my graph. Remember, height is a y value. 12 is going to be somewhere in here. They're asking for the first and second times. Now I'm going to have to consult my calculator about this one. I don't know exactly where that is. So it might be here and here, or it might be here and here. So we're going to go look at the calculator. So now I'm going to go back to my graph. Sorry about that glare. I'm going to go back to my graph, which is on this page here. So I can hit this left arrow. I'm going to hit Control left arrow to go back there. And I'm going to hit Tab, and I'm going to graph the line y equals 12. Now, do not forget, the calculator changed the window on me. If I go Menu 4-1, I'm looking around 11. I don't want to look at 11. My answer should be somewhere between like 0 and 2. So keep track of what happened here. So I'm going to go back to that 0 to 5. Okay, so I'm looking for the first two intersections. It does not look like they're going to intersect there. So we're going to look for this one and this one. Menu 6, 4. I'm going to go find the first intersection, click on one side, drag it to the other. Menu 6, 4. I'm doing it again. I'll write the numbers down later. And find the second intersection. Now, I'm going to add a digit here, right? We should always look for 3, but my answers are at the bottom of the page. Again, I already know the y value. That's what they gave me. I'm looking at the x's, or the times. So my first time, 0.526. My second time, 1.974.